Hey guys, welcome to another video. In this video, we're going to tackle some questions about Hopital's rule, which is lesson 4.7. So in the first question, they asked us to find the limit as x is going to 0 to e to the power of x minus 2 over x. Now, the thing about Hopital's rule is that you're not allowed to use it unless if the answer for the limit is 0 over 0 or infinity over infinity. So in any exam, shape, or form, if you didn't mention that the answer of this limit is 0 over 0 or infinity over infinity, you're going to lose a mark. So we don't want that, obviously. So simply put, what you're going to do is basically you're just going to replace x with 0 in the beginning. So you're going to do 2e to the power of 0 minus 2 over 0. Now we know that e to the power of 0 is 1. So that means you're just going to do 2 minus 2 over 0, which is going to be 0 over 0. So in this case, we're going to use Hopital's rule. So hold on one second. All right. So we're going to use Hopital's rule in this case. Hopital's rule states that we're going to find the derivative of the top one by itself over the derivative of the bottom one by itself. So limit as x is going to 0, it will be 2e to the power of x over 1, which is going to be equal to 2e to the power of 0 over 1. And this is going to be 2 over 1, which is 2, because e to the power of 0 is 1. So this is the final answer for limit number 1. Now, limit number 2. It is 3x minus 3 over ln x. Again, you have to first of all solve the limit naturally. You have to show me that this is 0 over 0 or infinity over infinity. So 3 multiplied by 1, negative 3 over ln 1. Now 3 minus 3 is going to be 0. Ln 1 is going to be 0. So we use Hopital's rule. So the derivative of the numerator is very simple. It's going to be 3. And the derivative of the denominator is going to be 1 over x. So now if you're going to replace x with 1, you're going to get 3 over 1 over 1, which is 3. And that's basically it. Now, for question number 3, it gets a little bit more interesting. They said they have like these square roots all around the place, so it could get a little bit challenging. However, it's not that big of a deal. So first of all, you need to replace x with 2. So you're going to get 2 plus 2 minus 6 minus 2 over 2 minus 2. Now, this one is going to be the square root of 4, which is 2. And this one is going to be the square root of 4, which is 2. And this is going to give me 0 over 0. We use Hopital's rule. So the derivative of the top one is going to be, now since this can be written as 2 plus x to the power of half, and this is 6 minus x to the power of half, according to chain rule, the half is going to go down, 2 plus x, and then the new power is to the power of negative half, and then you multiply by the derivative of inside. In this case, the derivative of inside is just 1. However, in the second one, half is going to go down. You're going to have 6 minus x to the power of negative half. But the derivative of inside over here is negative 1 because you have 6 minus x. So negative 1. And the denominator, the derivative of the denominator is just 1, right? So you just keep this the same way. You don't need to write it over 1, obviously. Now you just need to replace x with 2. So it will be equal to half 4 to the power of negative half minus half 4 to the power of negative half multiplied by negative 1. Now, since you're going to multiply by negative 1, so let's erase the negative 1 over here and just replace this with a plus, because negative 1 times negative number is going to give you a positive number. Now, this is going to be equal, like if you plug it in on a calculator, it's just going to be equal to 4 to the power of negative half, which is 1 over 4 to the power of half, which is 1 over 2. Okay. Now, if you're going to solve it like manually if you want. Half plus half is going to give you one whole number, so it's going to be 4 to the power of negative half. And 4 to the power of negative half is 1 over 4 to the power of half. So 1 over the square root of 4, which is 1 over 2. But yeah, you can use a calculator for that. It doesn't make any difference. So over here, this is which number? Number 4. So again, you replace x with 0. So you're going to get 3 to the power of negative 3 minus 1 over 27 over 0. Now 3 to the power of negative 3 is literally 1 over 3 to the power of 3 minus 1 over 27 over 0. Now 3 to the power of 3 is 27. So technically you're going to get like 1 over 27 minus 1 over 27. So this is going to be 0 over 0. We use Hopital's rule. So limit as x is going to 0. The derivative of the numerator, the negative 3 is going to jump down. 3 plus x to the power of negative 4. You multiply by the derivative of inside, which is 1. The negative 1 over 27 is going to be disappeared because it's a constant, so it's a 0. Over 1. So let's just stop over here. We don't need to write it over 1. And then you just replace x with 0. So it's going to be negative 3 to the power of negative 4. That's it, because times 1 is not going to affect anything. So it will be negative 3 over 3 to the power of 4. So it is going to be negative 1 over 3 to the power of 3 by simplification. 4 is going to become 3. The 3 is going to be removed. Negative 1 is going to remain. So negative 1 over 27. That's it. Now, the last question, number 5. If you replace x with plus infinity, you're going to get 2 plus infinity to the power of 2 over e to the power of 2 plus infinity, which is essentially plus infinity over plus infinity. Use HR. Now, this one is going to give you limit x is going to positive infinity 4x over 2e 2x. Remember that the derivative of e to the power of 2x is the same as the derivative of e to the power of u, which is going to give you u prime e to the power of u. So 2e to the power of 2x. So 4 divided by 2 is going to be 2, right? But if you're going to replace plus infinity again, you're going to get plus infinity over plus infinity again. If you're going to replace x with plus infinity, similar to the first step. So we can use Hopital's rule again. So you're going to get limit as x is going to positive infinity 4 over, this is going to be 4e to the power of 2x. Now if you replace x with plus infinity, you're going to get 4 over plus infinity. Even if you don't simplify, it's going to give you the same exact answer. Any number over infinity is going to be 0. Now in this case, just as an extra information, because x is going to infinity and the answer is a number, this means that y equals 0 is a horizontal asymptote. Okay, so just food for thought. And of course, this is just an extra information. This does not have to do with the question itself. But like, yeah, you can use it as a practice drill, of course. So this is it for this video. This is a very short video demonstrating Hopital's rule. Hope you understand. And if there is any correction for any mistake, the possible mistake that I've done, please check the comments. If you have any questions, please comment as well. Thank you so much.